Solving nonlinear systems. Nonlinear systems means instead of having two lines, you've got a line and you've got another line and their solution is where they intersect. Now you have perhaps a line. Let's do this in color. You have a line that would represent equation 1, and in equation 2 you've got a parabola. So now you've got two intersection points because a parabola could potentially intersect a line in 2 points. It doesn't have to intersect it in 2 points. It could just intersect it once, or maybe it never intersects at all. So that's something that we have to look out for now when we're solving nonlinear systems. So we can just draw that picture because we don't know which one we're going to have. Are we going to have the first situation, the second situation, or are we going to have the third situation? This one, or this one? We just don't know. So algebraically, this is what we're looking out for. Now, it says solve by substitution. So what we're going to do is we're going to take equation 1 and we're going to solve it for y. If I solve this for y, I get y equals 3x plus 2. Okay, I bring y over to the right-hand side, I bring 2 over to the left, I get y equals 3x plus 2. The second equation is 2x squared minus y equals 0. I'm going to take the expression for y and I'm going to substitute it into the second equation. So instead of 2x squared minus y, I've got 2x squared minus all of 3x plus 2. I'm going to distribute the negative, and I'm going to solve. It's a trinomial, a quadratic trinomial, so hopefully it's factorable. We get back to 2x squared by multiplying 2x times x, and we get back to negative 2 with a 1 and a 2, positive 1, negative 2. Let's see, negative 4x, positive 1x, that is indeed negative 3x. It works, so I'm going to erase my work. I get x equals negative 1/2 and x equals 2. So I've got two ordered pairs, one in which x is a 2 and the other one x is negative 1/2. Now I'm going to take each of those values and I'm going to plug it back in. So I'm going to take this negative 1/2 for x and I'm going to plug it back in for x into the linear equation. So I get negative 1/2 times 3, 3 times negative 1/2 plus 2, negative 3/2 plus 2, notice how I made that a fraction, is 1/2. So when I put negative 1/2 in, I get positive 1/2 out. And now we're going to use the second x. X is 2. We get 3 times 2 plus 2 is equal to y. 6 plus 2 is 8. And our two ordered pairs, which means we have this situation right here, 2 comma 8 and negative 1/2, positive 1/2. Now in the next example, we're going to solve this by graphing. So make sure you have your graphing calculators out. We're going to solve both of these equations for y, and we're going to put those values into our calculator, and we're going to look for our intersection point.